We're going to have a look at what negative exponents mean. If we've got something like p cubed over p to the 4, we know what that means. At the top, we've got p times p times p, and at the bottom of the fraction, p times p times p times p. We could then go ahead and cancel out the 3p's on the top with those on the bottom, and we'll see that what we'll get is 1 over p. But we've also just been dealing with that rule for division, that when we are dividing, we're going to subtract the exponents. So p to the 3 over p to the 4, using that rule, should be p to the 3 subtract 4, and that is p to the minus 1. Now, obviously, we don't want p cubed over p to the 4 to be able to be equal to two different things, and so that's why it makes complete sense for us to say that p to the power of minus 1 must be equal to 1 over p. Let's look at another example. For example, if we had p cubed over p to the 5, and we wrote out what that means, and then we did our cancellation, you will see that what we have left is 1 over p squared. But if we again apply the rule that we've established for division, we would have to say it would be p to the 3 minus 5. And that is p to the power of negative 2. And so, to keep things working nicely, we'd have to have that p to the negative 2 is equal to 1 over p squared. And so, in general, when we have a negative exponent, p to the power of negative n, it is equal to 1 over p to the n. And just a quick word of caution, again here we don't want p being equal to 0 because of course we can't divide by 0. So any other number is fine for p except for 0. Alright, so let's look at some numbers and see if we can make sense. So let's see what is the difference between having 10 to the power of negative 2 versus having 10 multiplied by negative 2. Well, 10 to the power of negative 2, when there's a negative in the exponent, it doesn't make the number negative. It simply tells you to go 1 over the number. So it's going to be 1 over 10 squared, and 10 squared is 100. So 10 to the negative 2 is 1 over 100. In contrast, 10 multiplied by negative 2 is negative 20. We're going to work a bit further with negative exponents. First thing we need to do is just have a quick reminder of division with fractions. So if you needed to do something like this, then what you do is you follow our rules for division by fraction. You keep the first one as it is, you change the division to a multiplication, and then you flip the fraction. And so that will be, well, 5 is just 5 over 1, remember? And so then what you'll get is 5 times 3 is 15, 1 times 2 is 2. So you get the answer of 15 over 2. The other thing you need to just remember is your fraction line acts like a division, right? So if, for example, I had 4 over, let's just make it 4 over a half, then what that means is 4 divide by a half. Now you should be able to get that answer quite quickly just using your head. How many halves are there in 4? The answer is 8, but let's just do it using the process for division. It's 4, and you change that to a multiply, you flip that, and you're going to get 4 times 2, which is 8. Now let's get to what we really want to get to here. X to the power of negative 1. Remember that negative 1 as an exponent has nothing whatsoever to do with negatives. It is just telling you that what you have here is 1 over x. So the negative 1 in the exponent just tells you you're talking about 1 over x. Now, the second one is where things get nicely interesting. What you have is 1 over, and now x to the negative 1 is just 1 over x. So like we've just seen, that's 1 divided by 1 over x, which is going to be 1, and then you change this to a multiplication, turn that into an x over 1, and so you've got 1 multiplied by x over 1, which is x over 1, and x over 1 is just x. So notice here, if you've got x to the negative 1, it becomes 1 over x. And if you've got 1 over x to the negative 1, it's kind of, this becomes up, it just becomes x. It's almost like it swaps position. Okay, I want you to try these two. So what you're being asked to do is to write them with positive exponents. Pause the video and try it now. All right, so for the first one, this negative here is just telling you that the whole of this thing here is negative. So it will remain negative. But then we've got to deal with the exponent. And what we've got is 3 to the negative x. We know the negative in the exponent simply means 1 over. So we've got 1 over 3 to the x. And in this case here, we've got a 5. And then we've got x to the power of negative 1 at the bottom. So you know that that is 5 over 1 over x, which is 5 divided by 1 over x, which is 5 times x over 1, which is just going to be 5x. Or if you want to take the kind of shortcut thing, which you'll start to notice after a while, if you've got a thing with a negative exponent in the bottom, the denominator of a fraction, it can simply come up to the numerator and become positive in the exponent, which will be positive 1, and that we know is just x. Let's look at some extra work that includes working with negative exponents. If you're asked to simplify something like this, remember you just need to work with each of the bits individually. So first let's just do 12 divided by 3, and that gets me the answer of 4. Now we're going to deal with the a's. So with the a's, you've got a to the 8, and it's divided by a to the 10. So in terms of simply writing, using the rule for division, it's going to be a to the 8 minus 10. And then we move on to deal with the b's. You've got b to the 11 at the top and b to the 2 at the bottom. So it's going to be b to the 11 subtract 2. And so that is going to be like that. Sometimes they like to ask you to write this with positive exponents only, so to give your answer with positive exponents only, in which case you'll leave the 4 where it is, you'll leave the b to the 9 where it is, because those have got positive exponents, but you'll know that a to the minus 2 simply means 1 over a to the 2, so it will go to the bottom. And just notice you could have seen that right from here. You've got a to the 8 at the top and a to the 10 at the bottom. So you've got 8 a's multiplied together at the top and 10 of them multiplied together at the bottom. So 8 of these ones at the bottom will cancel with the 8 at the top, and you're left with 2 a's multiplied together at the bottom, which is where that a squared comes from. Okay, how about a revolting one like this one? Well, it's again easy enough. If we look at the numbers, we've got a 3 at the top and a 6 at the bottom. So we can go ahead and do a bit of cancelling there. You'll have divide by 3 gives you 1, and divide by 3 here gives you 2. So what you've got in terms of numbers is 1 over 2. Now let's have a look at our p's. We've got p to the negative 3 at the top and p to the negative 6 at the bottom. So we can use our rule for division. It's going to be p to the negative 3, and then you've got to subtract what's at the bottom. Now we just need to sort that out, and that's going to be p to the negative 3 plus 6. And so what we're going to get is p to the power of 3. Okay, I want you to try these two for yourself. You're being asked to simplify them and then write them the answer with positive exponents. Pause the video and try it now. Okay, let's deal with the first one. First we multiply the numbers together. 5 times 2 is 10. Then we deal with the x's. We're multiplying, so we're going to add the exponents. So that's x to the 1. So we're going to have 1 plus negative 4. And then we're going to have y negative 3 plus 2. So we get 10. X, 1 minus 4 is negative 3. And negative 3 plus 2 is negative 1. And they've asked us to write them with positive exponents. So the 10 just stays a 10, but x to the negative 3, it becomes x cubed in the denominator, and y to the negative 1 means y needs to go to the denominator. It'll be y to the 1, but we know y to the 1 is just y. Okay, this next one, if we do it the long way round, what I have is p to the negative 2 divided by q to the negative 3, which means I've got 1 over p squared divided by 1 over q cubed. And I know that with fractions, I turn that into a multiplication, and then I flip this so it becomes multiplied by q cubed over 1, which becomes q cubed over p squared. But hopefully, as you get faster and faster with this, you will just be able to recognize that this negative means it simply needs to come down to the bottom and become positive, and the negative, when it's in the denominator, will simply result in it going up and becoming positive. That's the shortcut. We're going to do some more simplifying with exponents, but this time where the numbers are in the base. Okay, so we know that we've got a whole lot of rules that we can use to deal with exponents when we want to simplify. So if we're asked to simplify something like this, we can apply these rules. The only thing to note, of course, is the rules that go something like this. You know, if you've got two things multiplied together, you add the exponents. If you've got two things divided, you subtract the exponents. It only works if you've got the same base. And here you've got a 2, an 8, and a 4 as the base. So you actually aren't going to be able to apply these rules. So what we need to do is get the base the same. But obviously you know that 8 is 2 cubed, and you know that 4 is 2 squared. So we can actually get it in terms of the same base. So let's start by doing that. We're going to write everything in terms of 2. So 8, in place of 8, we're going to put 2 cubed. And that's being raised to the 2x. And in place of 4, we're going to put 2 squared, and that's getting raised to the x. So now we can go ahead and use this rule, right? A to the m all to the n is a to the mn. So it's 2 to the 3 all to the 2x is 2 to the 3 times 2x, which is 2 to the 6x. And the same thing for the same rule we'll use at the bottom. It's going to be 2 to the power of 2x. Now we go ahead and we apply our rules. Here, when we're multiplying numbers, we know we add the exponents. So what we'll get is 2 to the negative x plus 6x. And then, of course, when we divide by 2 to the 2x, we're just going to subtract the exponent. So we're going to subtract 2x, and so what we'll have here is 2 to the negative x plus 6x gets me to 5x, subtract 2x gets me to 3x. And that's a perfectly decent answer as is, but you could also note that this is the same as 2 cubed to the power of x, and 2 cubed is 8. So another way of writing this would be 8 to the power of x. Either way, this or this would be fine. I just want you to notice that 2 to the 3x is the same as 2 cubed to the x, so it's the same as 8 to the power of x. Let's have a look at another quick example. This one here, we can see that 15 is 5 multiplied by 3. And so what we get here is that we've got 5 to the 4x, and then 3 to the 4x, and then 5 to the negative x, and then 5 to the 3x. So what we can simplify and sort down are the things which have the 5 as the base, because we can only use our rules of exponents when everything has the same base. And so we get 5 to the 4x plus negative x, and then subtract 3x, and that 3 to the 4x we can do nothing with. And 4x subtract x gives me 3x, subtract 3x gives me 0, so I get 5 to the 0 times 3 to the 4x, and 5 to the 0 is 1, so 1 times 3 to the 4x is 3 to the 4x. Again, that's completely fine to leave it like that, but you could also take note that this is 3 to the 4, all to the power of x, and 3 to the 4 is going to be 81. So this is 81 to the power of x. Let's do a couple of examples where we look at using the exponent rules. Okay, so the first thing we need to make sure that we know and understand our exponent rules really well. Then, if we're asked to simplify, and in this case we're being asked to express it with positive exponents only, something like this, what we're going to do is just systematically go through and apply our exponent rules step by step. So we're going to start off by dealing with this squared. So it's this whole thing in the brackets that's squared, so we must go and square each little bit in the brackets. So 3 squared gives me 9. P cubed squared is going to require this rule, and so it's going to be p to the 6. And q to the negative 1 squared, again we'll apply that rule, so it's negative 1 multiplied by 2, so it's negative 2. And then let's just write down what we still have at the bottom. Now we're going to go through and we're going to deal with the fraction line, and remember your fraction line is your division. Okay, so 9 over 6, those are just plain old good old numbers, and so we can simplify that fraction. It's going to be 9 over 6, divide top and bottom by 3, it's 3 over 2. So that's back to primary school, right? Those are just plain old numbers. 9 over 6 is the same, can be simplified down to 3 over 2. All right, now we're into high school with our exponents. So we've got p to the 6, and then we're dividing by p to the negative 2, so we must subtract off negative 2. And then we've got q to the negative 2, and it's divided by q, which is q to the 1, so we subtract off 1. So what we have here is 3 over 2, and then p, 6 subtract negative 2 is the same as adding 2, so it's p to the 8, and q to the negative 2, going down further even 1, is q to the negative 3. Now they asked me to make sure that I had it with positive exponents, and I know that q to the negative 3 is just 1 over q cubed. And so if I want to put it all together nicely, at the top I'll have a 3 and the p to the 8, and in the bottom of the fraction I'll have a 2 and a q cubed. One quick further example, if we're asked to simplify this thing over here, again, let's just systematically go through it. So first we're going to be dealing with the squared, so each thing in the bracket needs to be squared. So negative 3 squared gives me, I need a pen, gives me 9, and x to the negative 3 squared will give me x to the negative 6. And then we've got plus 2x to the 5. Now the question is, can we combine these two things here? So could we say 9 and 2 is 11, and I don't know, do something with x to the negative 6 and 5 somehow? Now just because we've done exponents doesn't mean you need to forget all the stuff that you did in the beginning in algebra. In algebra, when you are adding, you need to have like terms before you can add. And remember, like terms have to have the same variable, which we do have here, but it also has to be to the same power, right, to the same exponent. And here we've got x to the negative 6, x to the 5. So this and this are not like terms, so we can't do anything further. This is as far as we can go. We cannot add them because we can only add when we have like terms.